Okay, so for section 2.4, I am doing question 203, which asks me to find the surface area of the volume generated when the following curves revolve around the y-axis. And the equation that I have is y equals the cube root of x, and that's from x equals 1 to x equals 27. So the first thing I'm going to do is I'm going to write down those equations, and then I'm going to write down the bounds from 1 to 27, and then I'm going to figure out what the y values are at 1 and at 27 so that I can get like the slope formula, or at least put it in terms of y, because the surface area formula is in terms of y and it's being rotated around the y-axis. So let me write this down and then I will share my work. So I found that at 1, y equals 1, and at 27, y equals 3. So if we just put this in terms of x, x equals y cubed. So the slope is just dx dy. So we can take that reverse power rule and we pretty much know that the slope is 3y squared. And now that since we have that slope, we can put that into our formula. Area or surface area equals 2 pi the integral over the range, the x range, which would be from 1 to 3, and then inside the function it would be y cubed times the square root of 1 plus 3y squared squared. So I'm gonna write that down, and then so after writing down and finding all the components for the equation for surface area, this is what I got. Surface area equals 2 pi times the integral over 1 to 3, and the function inside is y cubed times 1 times square root of 1 plus y squared, or 3y squared squared times dy. So what I'm going to do now is I'm going to try to simplify this a little bit more and then get to, I guess, a simpler place where I can integrate and find the function that I need to plug in the values to. So this one did actually take me a little bit longer to figure out how to simplify down. Once I distributed the square inside the equation, I got 2 pi times the integral over 1 to 3, and then the inside function is y cubed times the square root of 1 plus 9y to the fourth, and then all of that times dy. And the next thing I did was I actually tried to distribute a factor to the inside of the equation as well as to the pi portion of it, so that when we took the integral, we can just have one term, just the 1 plus 9y to the fourth term, because I wanted to get the y cubed to the bottom after the integration. So the factor that I found was 36 for that. And as you can see, sorry, it's still focusing up. Once I distributed the 36, I put the 36 as a denominator on the outside, so 2 pi over 36, and then the integral from 1 to 3 of 36 times y cubed times 1 plus 9y to the fourth, all of that is in parentheses, to the half power since it's a square root. And if we actually take the integration of that, we can leave the pi, 2 pi over 36 alone, but that does simplify into pi over 18. The actual integration cleans up to 1 plus 9y to the fourth, all of that in parentheses, to the 3/2 power over 3/2. Because again, once you do that integration, the y to the fourth power, or sorry, once you do that integration, the y cubed gets canceled out since it goes to the denominator, and you are just left with that simplified form that I just read. And you can now, you can now multiply the inside by 2/3, since you want to get rid of that denominator, and that would also like impact the pi over 18 term. So once you multiply that by 2/3, you get pi over 27 times the integration of 1 plus 9y to the fourth, all of that is in parentheses, to the 3/2 power from 1 to 3. So now all that's left is we just plug in the values and then evaluate for the surface area. So what happens there is it's pi over 27, and then in brackets, the first part of that is 1 plus 9 times 3 to the fourth, close parentheses, all of that to the 3/2 power, and then subtract the value of the function when it's at 1, and that would just be 1 plus 9 to the 3/2 power. And after you do the math, I plugged it into a calculator. I got 2,291.26 squared units as the surface area of this region.